Hello, in today's video we're going to be discussing balancing equations. And so in order to figure out how to balance an equation, we need to figure out what an equation is. So let's take a look at this reaction. Propane plus oxygen, and anytime we have a reaction where you're adding oxygen to a system, you're actually burning it. So propane burned in the presence of oxygen produces CO2 and water. So over on the left side we have the reactants. Over on the right side of the arrow we have the products. This arrow in the middle is called the yield arrow, and it just leads from reactants to products. You'll also notice that there's a subscript with a letter on each of the molecules here. So this has a G, the C3H8 has a G, the O2 has a G, the CO2 has a G, and the H2O has an L. So what that means is the subscript indicates the state of matter. Now we're going to have 4 different types of matter in this class. We're going to have solid, liquid, gas, and aqueous. And we'll get to aqueous as we get further along in the semester. So for right now we have this type of reaction. Propane plus oxygen leads to carbon dioxide plus water. Now there's a law, a mass law in the world of chemistry called the law of mass conservation. And what that says is that the total mass of everything on the left of the arrow needs to equal the total mass of everything on the right of the arrow. It's called the law of mass conservation. You can't create or destroy matter. The weight is going to be the same on both sides of this equation. Now in order for that to be true, we have to have the same number of each element on the left as we do on the right. Now if we look here, we can easily see that carbon, there are 3 carbons on the left of this reaction, but there's only 1 carbon on the right. So this does not satisfy the law of mass conservation. So in order to do that, we go through a procedure called balancing a reaction. And I'm going to show you the procedure. You don't have to use this procedure, but this is the procedure that I've been using for years and years and years, and is the procedure that most chemists use. So let's see how we balance an equation as an unbalanced equation. So what I do is I start by listing all the elements on both sides. So we have a carbon over on the left, we have a hydrogen on the left, and we have an oxygen on the left. And I count the number of times that element appears on the left side of the arrow. So there are 3 carbons, there are 8 hydrogens, and there are 2 oxygens. I do the same thing over on the right. I go carbon, hydrogen, oxygen. Now, if you're doing this procedure and you see an element that's on the left that's not on the right, something's gone wrong. So that's not a proper reaction. So they have to have the same elements on both sides. We count on the product side, 1 carbon, 2 hydrogens, and 3 oxygens. Now there are a lot of different tricks to figuring out how to balance this. Some of you are going to be very good at balancing equations, some of you are going to be very bad at balancing equations. It just comes with practice. You can always become a little bit better by practicing a lot of these. So since we see on this reaction, carbons are not balanced, hydrogens are not balanced, and oxygens are not balanced. So what we need to do is we need to put a stoichiometric coefficient. Sounds like a really big advanced word, but all it means is a number in front of all of the molecules within this reaction that require it, such that when you multiply that number through by the molecule, you can balance out an element. So how does that work? Let's just go top to bottom here for the reaction. We have 3 carbons on the left, we only have 1 carbon on the right. So what that means is I need to put a 3 in front of the carbon dioxide, and that 3 is now our stoichiometric coefficient. So we have a 3. This 3 is now multiplied to everything inside of that molecule. 3 times 1 becomes 3. We have now balanced the carbons, but now the 3 is also multiplied by the oxygen, which is 2. So there's 6 there, plus the 1 from water. So now we have 7 oxygen atoms on the right, only 2 on the left. But the good news is we have balanced the first element, carbon. So we don't have to worry about carbon anymore. Second step, let's balance the hydrogens. There are 4 hydrogens on the left, 2 hydrogens on the right, so I'm going to need a stoichiometric coefficient in front of water to make this become an 8. And the way I do that is I put a 4 in front of the water. 4 times 2 is 8. 4 times 1 is 4, plus the 3, I'm doing the oxygen now. 4 times 1 oxygen plus 3 times 2 oxygens is equal to 10 oxygen atoms on the right, only 2 on the left. So we're getting closer. We have balanced out the carbons, we've balanced out the hydrogens, now we need to balance out the oxygens. Well, now in this case, we have more oxygens on the right than we have on the left, so we need a stoichiometric coefficient on the left. Here we have 2, we have 10. If I place a 5 in front of the oxygen on the left side, I get 10. And now this is a balanced chemical reaction. Okay? There's one, for every 1 propane, it requires 5 oxygens to burn. That produces 3 carbon dioxides and 4 waters. And we can see that this is balanced because we know the numbers on both sides. They equal each other, so this is a balanced chemical reaction. It satisfies the law of mass conservation. Now, what does this allow us to do? Okay, I'm going to erase the procedure. Now we have a balanced chemical reaction. What can we do with this? Just like what we've been doing where we can convert within a molecule, so let's say I had 1 mole of propane, I know I have 3 moles of carbon within that 1 mole of propane. The stoichiometric coefficients now allow us to convert from one molecule to another. So let's say I have 2 moles of propane. Okay. If I want to figure out exactly how many moles of oxygen are required to burn 2 moles of propane, I use the stoichiometric coefficients to convert between molecules. So what I can do is for every 1 mole of propane, the 1 came from the, there's no number written in front of propane, but that indicates a 1. For every 1 mole of propane, there are 5 moles of oxygen. The moles of propane cancel. We multiply these out. 2 times 5 equals 10. So if you had 2 moles of propane, it would require 10 moles of oxygen to completely burn it. So these stoichiometric coefficients from the balanced chemical reaction tell you how to convert from one compound to another. And this just now opened up a whole wide range of different conversions that we can perform for any reaction that we're given. So with that, I want to say have a great night. I will see you all in class tomorrow.